Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode, we're gonna take a closer look at ARC Steam Rocket. So let's dive right into it. Now, before we understand steam rocket, we must understand water rockets. Now, here I have to simplify this very, bluntly. Water is inert. Basically, it's an exhaust byproduct. It's a burnt. Basically, same way you can't burn carbon dioxide, you can't burn water. So you're not getting basically chemical energy out of it. What you are getting is a propellant mass. Think of it this way. Let's say you are in space. How the heck your rocket engine is working? Basically, it's relying on action equals reaction. So it's throwing things and getting pushed back. So that is what's happening here. Water is not doing anything magical, like magically turning into rocket fuel. It's just a mass that you are throwing away. Now it's a very simple in terms of physics, and you can test it out with yourself. You can like literally go to any mall and find this sort of water bottle rocket. And the easiest way to understand why mass is so important, think of it this way. You pressurize this rocket, water rocket and all that. Why don't you just pressurize with air? Because even though air could have more pressure, it simply does not have enough mass to push that bottle up. It's like, but you have water, it's like. So that is why mass is important. So that's what is happening, like taking this design, pushing it to next level. Now again, this is happening on water. Steam could give you even more power. Now how will you get steam? That's up to you. You can use chemistry, you can use nuclear reactor, you can use microwave. That's up to you. So that's how water rockets work. So let's get it. How does understand the basically steam aspect of it. Now, throwing water, action equals reaction. That's very simple. Now, in terms of visualizing how much power we are talking about, because we are familiar with rocket engines. Like even a tiny rocket engine makes enough sound that you're like, okay, this is some serious stuff going on. So how do you visualize what kind of power water has? Mythbusters did a very interesting video about that, like where they were levitating a car using water jets and something like this. You can check that out. I have provided the video link down below. So you can understand like the physics is absolutely simplified on this. It's like nothing magical. It's just like, okay, you do it. Now question is, how the heck you gonna provide that kind of water? Like they were consuming hundreds of gallons per minute. So flat out, it's a hundreds of gallon water tank is just not gonna provide power for long enough to do it. So it's like now, okay, you want to go to orbit, or you want to go for like let's say 10-second burn or 20-second burn. In those sort of scenario, you need something better. Now, how do you get water better? Well, you heat it up basically, because all we are talking about is basically mass being thrown. And you can improve the efficiency by heating it up, basically making a steam rocket. Now this is one of flat earther who was like, I want to go to space and see it out, but again, you do not become to be astronaut if you are like flat earther. So he built his own rocket. Now he was utilizing steam rocket, but he was like pressurizing it beforehand. Then now it does work. Physics is absolutely true, and it is better than just throwing water. Like if you're just throwing water, okay, good. If you're throwing hot steam, awesome. Now, be mindful when I'm saying this sort of thing, and it does work, physics is absolutely true, it does come with one serious consequence, because you do not have enough energy to liquefy it. Basically, because we are not talking about nuclear reactors or some sort of a ground-based microwave projector. You do not get a lot of specific impulse. Your specific impulse will be best case scenario below 150 seconds. Translation is just not powerful. Basically, it does not have enough mileage. So even if you have a lot of power, a lot of thrust, it's just gonna be like, it's not gonna be like sustained. It's like a powerful thing, but it's a one-time deal kind of scenario. So what is ARC, the company that is trying to do it? Well, in simplest term, it is a very strange company. Now, when you are talking about Elon Musk and people were starting, like he started the space company on a shoestring budget. Now that is true in one regard, compared to like other space agency, he was running on fumes. Now compared to every Tom, Dick and Harry else, he had $100 million as a beginning point of his own money. So most of us, I am pretty sure, don't have $100 million to just go YOLO on it. So he does not have the luxury. Like basically, our company does not have that $100 million luxury. So outcome of that, they have a lot of ambition. Basically, everything they do, it's like attracting investor. Now again, SpaceX was doing the same thing. They were like trying to win the contract from NASA. So it's quite common. Only problem is because they do not have the starting seeding money or clear goal like SpaceX had. Is like they tried to build a hoverboard. They actually built it. It's just it was not so profitable unit, as in I'm gonna sell it and then taking the profit from that product and I'm gonna put into that. Then they built another drone, then they did other things, and before this was their main design that this rocket will be single stage to orbit. using aerojet. Again, did not pan out. Now this idea is scrapped and it's turned into second stage, and the first stage will be the steam rocket. So they will have a steam rocket that will push it high enough, fast enough that it can go from basically high vantage point to space. So you can understand they have a lot of ambition, and the whole selling point with water rocket, it's not cost effective, it's not other things of that nature. They are specifying it as a basically cleaner alternative. That kind of gives me pauses, like why you are selling that part, like whether it's clean or not. Like if they were saying it was cheaper, I would understand that, but they're never saying that it's cheaper. So I'm confused, because you have to understand lithium batteries are not cheap, and their budget constraints is really pushing them. Like they are really pushed. Even the fact that you can check their Facebook page is like, yeah, we bought this fluke meter and this key site meter just for calibrating and accurately measuring the temperature. It's like, yeah, that's $10,000. Again, Elon Musk would not worry about $10,000. He had $100 million to begin with. So again, that 100 million did help him out a lot. They do not have this luxury. Basically, ARC does not have that luxury. So what that steam rocket and all that is basically LAS25D, this whole contraption. So what they are doing is basically taking water, converting it into steam, using battery to sustain it, and they're gonna need a lot of battery. Now, so what is happening here is kind of interesting. Now, again, I have provided the link to their white paper below, but what they are trying to achieve, like I have not specified it to like 100%. It's like I'm a bit confused, like what the heck they are trying to do. It's like they have this tank. Now this is a very high pressure tank, so basically inside it water would be at very high pressure. Around target is around 15 bars. 1 bar is 15 psi, so kind of high pressure. Why? Basically, if you have high pressure water, you can heat it up to higher temperature. Basically, let's say 1 bar normal atmospheric 100 degrees Celsius, you have 15 bars, you can push it to 300 degrees Celsius. Side effect, your tank rather be very strong, otherwise it's gonna explode like a bomb, and I mean a bomb. So if you make a tank strong enough, then you can heat the water up to very high temperature, and the moment you let it off, it will turn into steam, providing a lot of thrust. So that I seem like that's what they are doing, because the mathematics on this is quite clear, not very clear cut, and their white paper is not that helpful. So again, they're still gonna need the battery, but be mindful the water would be charged on the launch pad. Basically, water in terms of temperature would be raised on the launch pad. The battery is only there to sustain it. Basically, they have the initial go point. Otherwise, battery will simply not have enough energy to do anything. So this is the thing that you can see. The video have a test launch of that. So question does become like, will it work? Like, can it actually do what it's supposed to do? Because they have very large ambition with this, like taking this design, converting into a aerojet design, because this is a bell nozzle. Their final design has a quote-unquote aerojet engine, and the idea is like this will take off as a first stage, launch that second stage, then come back, land same as Falcon 9. Only difference is Falcon 9 stage 1 is goes to very high altitude. These will not go very high altitude. They are very clear on that. Like they are targeting only 30 seconds of before separation, so they're not gonna go very far. So can it work? Well, physics on this matter is quite clear. It can work. Now here's the deal. One thing you have to learn. The moment you become an engineer, this is the first thing you learn. Science is here. Like let's say, oh, you should get 1 megawatt from your generator. Engineering is like, bruh, enjoy it. Start party if you get even 60% out of this. That's the very hard reality of the situation. It's like your physics will say, oh, you should get this much. Your inefficiency, your losses, and everything else current will barely allow you to get even, like, depending on designs or depending on other situation, not very close to it. Now physics is like almost like, let's say they need 100, physics is saying like you should get 105. But again, if physics is saying that, does that mean engineering can reach that high? Maybe, maybe not, because heck, we have LEDs. Like long ago, we used to have incandescent bulb that was 10% efficient. Now we have 99% efficient bulbs. So again, not a super easy situation, but probability is there that they could succeed, but very low probability. And battery is the limiting factor. Now, can I see a design or a future where water rocket can be made into a practical situation? Yeah, all they have to do is just change the water tank into a microwave receiver. Why microwave? Because microwave is very easy to aim. You can aim it. Basically, you can have like a whole array of flat field antennas and phase shift the beam, and then you can heat it up to like megawatts of heat and all that, and then you can just YOLO it. So physics is not saying it can't be done. It's just, can they do it? It's like very, very narrow margin. So this was my presentation on basically arc jet. I hope you liked it, learn from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.